You can go. Hardik, can you hear me?
Yeah,
Okay.
let me share my screen.
Perfect.
Hello everyone. So as you can see, my today's topic is about sharing is caring, KMM for Android and iOS. So let me start my talk by referring to some of my previous experience with KMM. So when I was writing my book, I wanted to include this particular topic. I did some spike around that, and then I find this topic very interesting, first of all. So I got some success doing it, but then I also realized that it is not up to the mark. I mean, developer might face some challenges while they want to accept this particular point, and it was not really ready for using for any of the big scale project. But after 6 months, suddenly I visited a particular page on their website, and I found that they have made an incredible changes. And now this topic is even more interesting. Working on this concept is far easier, and then it makes your life so easy. Even if as an Android developer, if you don't know iOS, that is also not a big deal to start with it. Of course, eventually you would need iOS skill as well, but I feel your iOS buddy would help you there. So let me share idea why I came up with this talk now. So there are some motivation factor for you
Hardik,
guys. I will.
sorry. Can you share on StreamYard the slides because are not visible?
uh,
Sorry about that.
no, it's okay. There you go. I think now it's good.
No, you have to share it on StreamYard. Okay. There we go.
There you go.
Now it's, yeah, perfect.
Yep.
Thank you.
Sorry, guys. That's me using StreamYard for the very first time. Okay, so yeah, let's begin. So the motivation point for this particular talk is, imagine you want to develop you want to develop some concept in both Android and iOS, but you don't know where to begin from. So, and you don't want to do the job twice because you are a very good software engineer. You just love drive principle. So, and also admit that you don't have iOS expertise. You are an Android champion. Um, you never want to compromise on the quality or maybe a swift delivery. You want to deliver the feature faster with top notch quality, and of course you don't want to compromise on some of the best practices which Android and iOS offers. You love the way view model works, you love the way repository patterns make stuff easy. You don't want to do compromise on it, and also somehow you don't like the existing cross platform technology, maybe like me. I'm not fond of all those things. So yeah, so that was a bit of an abstract part, but then what actually KMM will do for you is you would end up writing code once and you would be still able to use it on multiple places such as Android and iOS. It has a wider scope, but for our talk we are keeping it up to Android and iOS only. It reduces the testing effort greatly because you can definitely assure your QA and your team that if a feature is developed for Android, it would behave same in iOS as well if it is written inside your shared module. It has a less maintenance headache, and modification comes super easy because you only modify the code once and you get the same output on both the platforms. Another, of course, it has a great benefit of language like Kotlin, which is doing amazing. It's been 3 years. Kotlin is rocking into the dev community. It's statically typed language. You don't get surprises like other JavaScript framework. And for Android engineers, it doesn't really change anything. It's just like your day-to-day work. I would say you have that Android Studio window in front of you. You keep writing code either in shared module or Android application. It feels the same. And for iOS, for iOS engineers, I would say they don't need to care about whether code is written in Kotlin or Swift, because at the end, what KMM gives as an output is nothing but the dot framework file. You might feel it as a, just like any other Swift framework, and then there is no difference. And here is the main thing. So KMA is for everyone, not just for developer. Even, this point would make your stakeholders happy. If you plan it very well, it can reduce the development time of 30 to 40%. That means you deliver the features faster. Now, I was saying about that KMM is all about, adhere to the best practices and respecting what platform offers. Now, nowadays, if you can think of any modern app architecture, they would have, four major categorization. I would say data layer, where you can keep your HTTP calls, caching mechanism, stuff like that. And then comes business logic on top of it. You can have use cases, interactors, or maybe some of your common utility function. Presentation logic, key part, view model, presenters, and those sort of classes. And at the top, it could be your activity fragment, view controllers if it is iOS, things like that. So it has been divided into all this part. Now you might be thinking that, okay, do can I share each and everything? Answer is unfortunately no. What you can share if you are using KMM, so you can share your data layer and business logic in a 100% manner. Presentation logic, I would say it's possible, but based on my experience, I would suggest not to use KMM for the presentation logic. There are reasons, because presentation logic is really coupled with all the platform practices. iOS has their own way to do the stuff. View model has their own way to make the things work for you. For example, they are life cycle aware, configuration changes aware, many things. And KMM hasn't reached that point yet. So I would suggest on the presentation layer, keep the way you are doing right now. Now, those who has some experience on cross-platform technology, they might think, okay, why can't I use Flutter? Flutter is doing great. Xamarin, React Natives, they all are from giants and well-established, well-trusted companies. I would say I also have experience on working some of them, and even older framework like Cordova stuff. But let me again share what I feel about them. I have no grudges for them, but I would say they are pretty good for MVP and idea validation. Of course, even I would go for it. But then what I feel is they don't allow you to follow platform specific practices. I mean, come on, you can't use view model if you are using Xamarin or maybe React Native. They might have their own practices, and you need to respect it. It's not ideal for large or complex application. You won't design your app in Flutter where you have heavy requirement of taking care of security concepts. Of course, you would say no. C and C++ is a big contender, and it has an amazing potential, but you would end up changing the language as an Android engineer, and you may not be that much expert in those languages and not comfortable to work on. And all on this cross platform technology, you basically started feeling lonely as in you don't have much of a dev community support. You won't have much of a teammate around you when you are stuck and looking for help. And you struggle to deal with native APIs. Like, you would be always in question if you want to use something around location tracking, or maybe camera, or any other native functionalities. You would struggle, like even NFC maybe. I don't know if there are bridges kind of utilities available by all of this framework. You need to evaluate a lot of things before you pick any cross-platform technology. So these are the problems I feel and thought to share with you. And they also enforce the entirely new tooling system. I mean, you would be out of your comfort zone. Android Studio is an amazing ID. Every engineer would dream about it. So, and you would be out of that. So, yeah. Now, let me share a bit more around the architecture side. So how this entire things works. We're gonna take the example and learn everything step by step. But let me help you to start visualizing what we would be doing. So imagine there is a shared module. Now you can keep it, think like an existing Gradle module in your project. So think of some module. In that module, let's say you have a class which has two functions like get job info and get OS related information. And there you have a common implementation. And if you want to be, if you want to go a bit different for either Android or iOS, KMM allows you to be that flexible because they know what could be the requirement for many of the real-time applications. So you can try and try to differ with the default implementation, and you can say, okay, I would just override get OS information and do whatever I want. And iOS team might be saying, okay, I'm also gonna override and do whatever we have as a requirement in iOS. And at the end, if it is Android, you get .jar file as an output, and then you just consume it like any other jar file in your Android application. If it is iOS, as I said before in the introductory slide, you get .framework as an output, and you just import and link this framework file using your Xcode and get the app running. Your iOS app won't even have idea whether it is the Kotlin code or Swift code. For iOS application, it's just a framework, and that's the big deal. So now let me quickly cover how you can set up the KMM. It is pretty easy, and you would find it on the JetBrains website as well. So what tool you need is, you need Android Studio 4.0 and above, of course, to write Android and shared application. You need Xcode 11.3 and above. You might want to do some quick tweaks on your iOS code before you run them. Though you can run the iOS application from Android Studio as well. Yes, it's possible. New Android Studio is having all this facility. KMM plugin. So you just need to download the plugin from the preferences, and then this help you to select particular option into the project creation wizard. And then Mac OS. That's a bit of a constraint because right now, if you don't have Mac OS, you can't do anything. And the reason behind is the entire iOS ecosystem. The whole iOS ecosystem runs on Mac, so you have to use Mac for that. Okay, here is a plugin I was talking about. The plugin is compatible with, I think, Kotlin 3 and above. So make sure you are using that specific Kotlin version and the newer Android Studio, of course. This is how you would see a new option available into the wizard where you can select the KMM application like I'm showing here. And then once the project is created, you would see this kind of a lengthy directory structure where this root directory is a combination of three projects. One is Android Job Finder, which is your Android application. I have named it as Job Finder. Second is iOS Job Finder. That's your iOS application. And the third, the key part, is shared module. And that's where your shared code would live. Okay. So now let's understand what is the use case here. I I haven't taken fairly complex problem, but I have taken still relatively complex problem, which would help us to evaluate all the scenarios which you would face in any of your project, let's say. So use case is pretty simple. You can see in the GIF, it's running. What you need is, you need to display list of jobs available within UK. You want to allow your user to click on any of the list item and go to the detail part. And of course, information would be fetched from server. You want to write code using native components, no JavaScript framework or nothing like that. There to strong testing strategy. You don't want to compromise there. So with all those things, so I evaluated KMM on this four parameter. It could be many other parameter for your project, but I think these four are good enough to show the potential what KMM can do. Okay, so now you must be wondering, what are we sharing? And so again, now try to recall what we understood using our diagram previously, where I tried to explain the shared module part. So inside your shared module, you're gonna have a Ktor. So Ktor is nothing but the API client, or you can say simple HTTP client, which would help you to fetch or connect to your remote server and get the data. Ktor under the hood uses Android engine. So they have concept of Android engine and iOS engine. Android engine uses HTTP URL connection, which is the core class to make HTTP request. And iOS, if it is iOS engine, it would use NSURL session. It's a similar class of HTTP URL connection, but in iOS. Then they have tried to come up with a new serialization library, but you can use JSON, your favorite, or maybe Moshi, whichever you are using, you can do it. Since I find it new, I try to explore it. Plus, it also goes well with the rest of the stack. So I thought to use what they recommend, and it came nicely. I think it was quite easy to set it up. Once you have configured your serialization library, what we're going to do is we're going to create a class. Let's name it shared API client, which would use Ktor internally. And then shared API client would use job info class. Now, job info class is nothing but your entity, a simple data class, which holds your JSON data into the data class format. And Kotlin serialization library would do it for you. So and then at the end it just consume that class after parsing the JSON information. There is an independent layer, or you can say class, called os information.kt. This class is having a simple function which would help you to get the os specific information. I would go to that use case a bit later, but let's say it has this responsibility as well, and this entire thing fits into the shared module. Remember, you are not in Android project, you are not in iOS project, you are into that entirely separate shared module. Now let's actually start writing the code. We know the diagram and everything. We now maybe have some visualization in our mind. Now let's start writing the code. To start writing the code, you would add this sort of dependency in your shared module. Now pay attention to the title where I am highlighting which file I'm trying to modify. So it is the build.gradle file of your shared module. So you add this dependency just like you are adding in your Android project. The language and approach remains same. It's the KTS file. So I have tried to use the Kotlin DSL for the Gradle file. You add the dependency. There is a concept of source set. So within the shared module, there is something like common main. So whatever you add here, your common source set can access. Then there is Android main. Whatever you add here, Android source set can access. And same goes for iOS. Whatever you add here, the iOS source set would use. Now you might have noticed that I'm using Ktor for common main and then try to overwrite kind of a thing for Android and iOS main. Why I'm doing? Because I have to do it. Eventually, what Ktor would do, Ktor will pick up all this Android and iOS specific dependency and use Android or iOS engine out of it. And that's where it requires this dependency. And core dependency is just a core client, pure HTTP classes and talk around, networking stuff. So what we're gonna get from the server. So let's say it's the array of JSON, and within that array there are JSON objects, and each object holds some meaningful data like ID, what type of job it is, what's the company, what is the logo of company, location, and blah blah blah, job details, JD and all stuff. And this can be mapped with similar kind of a data class you can create. Now, this data class is also inside shared module. So ultimately, the same data class or entity is going to be used by your Android and iOS project. Yeah. Now we're gonna write the actual class which makes the network call. So let's call it shared API client as per our previous diagram. Again, pay attention, it is still inside your shared module. So you just define the URL, and then here is the important part. So you create HTTP client. This HTTP client is coming from Ktor, as I said, and then they have this very interesting syntax. and they try to use more of a harder function, use lambda syntax to make it more readable. So Kotlin is just being Kotlin here. Everything is so cool and readable. So you say install and then JSON feature what you want. So it's if it is retrofit, you can say you are trying to request some sort of feature. You are trying to build your OK HTTP client in context of retrofit and OK HTTP. It's the similar thing. You enable JSON parsing feature. You say what serializer you gonna use. Uh, I want to use the JSON serializer for using Kotlin X serialization. So I just define that part. Then calls the function, call it a get job info. It would return us the list of all the jobs which is available for UK market. I'm just trying to build the URL here inside implementation, and then use the same HTTP client which you have created before and call the get method out of it. Now here complexity is not around using get or post. So I have keep it things simple. It's get, but I have evaluated post parameters as well. Passing parameters in your post request is not a big deal. The concept remains same. You pass the parameter from your top layer to all the way to the bottom, and then try to build the request here. I would I would ask you to notice the way I'm using suspend function. So you are getting benefit of coroutine as well. We will see how this suspend function are consumed ultimately from Android and iOS project. But then there is another endpoint. So you can define all the functions based on your need. Whatever shared API client would offer you, just define all those functions, and then provide your entity class or data class accordingly. Now, once your shared client is ready, this is for now very thin layer of our API client, we can go and start thinking to use in Android. So to use in Android, you just need a project type dependency in your application level build.gradle file. And since it is in the same root directory, you don't need a proper Gradle implementation here. You just provide a project level dependency, and that's it. You get all the classes. And then you can say, so we want to create view model, right? And we want to use all the best practices which Android offers. So I want to use the view model. What should I do? If it is a repository, I would inject the repository instance here, right? Similarly, the idea remains the same. You just inject your shared API client here. Now you can use any dependency injection framework, and then you can say, okay, I want to have a job info property which is nothing but the live data. Inside your live data you put an emit statement because eventually you would be emitting all the data, and then just say API client dot get job info. Since live data has idea about coroutine scope and all the context and all the dispatchers, you get pretty much all the stuff for free. You just need to define your function suspend, call it here, and then on a view layer, I'm using view binding. So on a view layer, if it is you can do something like this: view model dot job info, and observe it, and then get the data back. That's it. View model, using a view model, you just inject it as I explained you here, and then it really changes nothing. On a view layer, you can see there is no KMM specific code, there is no RX related code or nothing. It's just a dumb view layer which you would like in any of your project. Now, what if it's an iOS? Now here things may take some time for you because you are an Android engineer. You may not have the complete idea how iOS works. But once you open the iOS project using your iOS job finder application, you can either open in Xcode because there you would get more readability. You can get the editor's help. Android Studio is not good in editing the iOS specific file. But when let's spend some time to understand that how shared framework is doing the magic. So once you set up a plugin, once you write your shared client, the plugin comes with a custom Gradle task, and your plugin also does something for your iOS project. It adds some script in the iOS module. This is the build phase of iOS. You can see this build phase as behaving like if someone requests a build, what step I need to perform. So let's say you need to run a Gradle task, Gradle W shared pack for Xcode. Now remember, this would run every time you build your iOS application, and once this task is run, it is going to build your shared module and convert all the stuff into Swift and Objective-C for you. So let's take a look how things got converted into the Swift compatible code. So once the build is configured, by the way, this plugin is doing for you. You don't need to add this step. This is just for the information purpose. And then you need to link them as well, just like any other framework. That is also done by your KMM plugin setup itself, and that's why plugin is so crucial. Without plugin, you can't get the things done easily. And then when I tried to check what it does behind the scene, I found that for all the shared code which I have written, it tries to transpile into the Swift, or some of the header files were in Swift, and some of the header files were written in Objective-C. I'm not sure what's the reason behind supporting both the stuff, but I imagine it could be somewhere around compatibility, because your shared module would be compatible with your Swift code and Objective-C as well if you are still in some legacy phase. And this entire shared framework supports iOS 9 and above. So from the backward compatibility perspective as well, you can think, the Kotlin team has really thinking and provided a good backward compatibility for even for iOS. Now this code may get bit tricky for you, and because you are not used to see the iOS code, but imagine, and I'm only going to explain how the network layer can be consumed. So let's import the shared. Now shared is our shared module, so we just import that. We create an API client class, a wrapper class. This is just a constructor, and then here is a function that provides a fetch job list. Now fetch job list would eventually call shared API client dot get job info, and then there comes some very iOS specific syntax where I want to handle some success scenario and error scenario. But then what I call is I dispatch it on the async thread. I transfer that request to the asynchronous thread, and then get the response back, or actually wait until I get the response back. Once I get the response back, I try to map whatever job info entity I have created inside my shared module to maybe something iOS compatible. So that's what I'm doing in the completion function. So that's all in iOS. As I said, after this layer, iOS don't need to worry about. They can just keep on developing the way they are. They can use Viper pattern, they can use view model pattern, whatever they want. It's all possible. Once you consume the function, you are on your own now, and then follow all the platform specific practices. Now, initially, I explained that Kotlin allows you to differ by platform if there is a requirement. Let's say what requirement I had. Again, it's a very trivial requirement, and on this particular part, Kotlin multi-platform mobile is proving a bit thin, I would say. I would explain some of the drawback which I feel while working on it. Now, you might notice on this screenshot that I'm trying to display the OS version and API level both for Android and iOS, but my code lives in shared module. But they have a separate path and separate requirement. So requirement is I want to display OS name and version in the app. It should be something like Android OS name API level. For iOS, it should be iOS and version, things like that. So how would you do that? Now Again, we are back to our shared module because we want to write a functionality in our common code base so that Android and iOS can use it. So in the shared module, within your shared module, you can say get OS information. Now this function is living inside one specific class, but the main important part to understand is the expect keyword. Now, and here is there is the entire new concept how you can override some of the platform specific requirements. So you can say expect. That means both Android main and iOS main would expect implementation for this get OS information. So your common module is expecting some implementation. It's kind of a contract, you can say in a simpler term. So now let's go to the Android main, and then in Android main, I try to override it. So it's not the typical override keyword like you use in Kotlin or Java, but you can say actual. So you define, you set your expectation, and then you provide actual implementation for it. That's the gist. So you say actual. All these are keyword, by the way. So you use the actual keyword, you override the implementation, or let's say provide the implementation. Now this typical code is doing nothing but trying to fetch the API level and OS version. You must be familiar with this. If it is iOS, you can again say actual. It is inside your shared module, but inside your iOS source set. Previous was inside Android source set. So you can say actual fun get OS information, and then provide the implementation. And here, just notice how KMM is coming up with some really platform specific name, and that's why I love it. They are respecting the platform. They say UI device. This naming convention is purely coming from the iOS. It's not iOS class, by the way. So don't think that they're trying to access some iOS core frameworks or namespaces. No, it's not like that. They are just mimicking some of the behavior, and these classes comes as a standard Kotlin KMM libraries. It is still Kotlin code behind the scene. You can check the source code and see what they are doing. Basically, they must have created some bridge internally. Now, once you have this part done, here is another interesting topic, and Uncle Bob is furiously looking at you. That dude, where is your test cases? You are not talking about testing. You develop the entire application, but no talk around test cases. It's not fair. So I evaluated few stuff around testing as well. Um, let's jump to straight to the main part. What if I want to unit test my shared API client? The requirement is this harsh. Okay. And then I want to try all this various stuff where I return multiple types of responses. I want all kind of assertion. I want 100% code coverage. Like many of you might be hearing this from your company leads that they want 100% code coverage. So I try to attempt that part. So you create a simple JUnit test class. You just add required dependency in your build.gradle file. Again, it's inside shared module. I would keep repeating this because it is very important to understand for all of you that code lives where, right? We did some switching between Android, iOS shared module. So I'm just keep repeating this to you. Now you can say global scope.launch because we are testing the suspendable function inside our shared API client. Both the functions which are making API call, they are suspendable. So you need this, just a scope to run the suspendable function. You can use any of your favorite mocking library. I was using Mockito here. So you just mocked your instance of HTTP client. Remember, this instance is not the shared API client, but this instance is your KTOR's HTTP client. So you are mocking the internal part, not the actual class which is under test. And then you just provide some dummy information. I have skipped that because it was really lengthy dummy response. So you just provide your dummy test response, and then you call the actual function which is under test, and then you can have your assertion just like normal assertion. You can say assert equal, list of what you are getting and list of what you have. And then you can call some verify methods on your mocked instance, and you can say, oh, I want URL to be exactly like this. And then this way you can verify or assert your URLs as well, that it has to match full time, it has to have a location UK. You can do whole lot of stuff. It's up to you how far you want to go. So that was all about testing the JUnit client. Um, Also, let's understand, what if I want to write espresso test case. So let me be very honest. When I was trying to do it, I kind of struggle a lot, because with espresso test case, what happens that you need to provide the you need to map your API client and map it to the mock server, let's say if it is a retrofit client. Similarly, here, Ktor also comes up with the Android engine, but I found that Android engine would be more useful if I am using Ktor client directly into my Android project. What if my Ktor client is inside shared, and I want to write test cases on my actual Android app? Because that's where I would make the network calls ultimately. So this bit I couldn't figure it out. I'm still trying to work, and I might be doing something wrong setting up the Ktor client, but who knows? Maybe it's the other way around, that maybe something is lacking. On iOS part, again, I was completely clueless that how iOS side can write their test cases as well. In worst case, what we can do is we can change our design a bit, where we try to inject our API client all the way from view layer to the shared module. Maybe this could be the solution, but I haven't got time to try it out there. Maybe in future. But this is where I struggled a lot, and probably you might struggle as well. So disclaimer. And yeah, now whatever we have talked so far, it is all for the greenfield project. It is very easy to start using KMM if it is a new project. For existing project, how do I do? You might have this question. Uh, there is not a proper solution to use it, but then there is an idea that maybe this would work, and this has been suggested by the Kotlin team itself. So let's say you have a new project, then things come easy. You write a shared code in your K module, you implement the native functionality, or I would say UI part in your Android and iOS project, and then ultimately use it in form of jar or the framework file. But if it is existing project, the way you should do is maybe take some time, plan your work in such a way that you can take out some Kotlin written code from Android, refactor it, and make it compatible with iOS, and then use it just like the way you were using for any of the new project. Another good thing which you can do is whenever you have any new requirement coming up in your project, and treat it as a new feature. So if it is a new feature, you can go back to the new project path, because you can easily do the modularized development, move everything into the new module, use or develop it using the KMM approach, and then things would be the same for you. And then this the burning question: is it ready for production? So here is how I evaluated this topic. I'm going to share this with you. So Kotlin ecosystem has developed all these component, and they have categorized them into four modules. Let's say experimental, alpha, beta, and stable. Okay, this means the Kotlin team is very committed towards KMM, because some of the features are already in alpha. They are not going to pull out this entire concept overnight. KMM is something new, and they're going to definitely make a lot of improvement. just like I experienced back in 2019. I felt that there are a lot of possible improvement required, and in June 2020, half of the problems were gone, and they came up with so beautiful solution about that. So wait for it, I would say. They regularly collect feedback and provide improvement as soon as possible. There are forums where you can give your feedback as a KMM user, and sometimes there could be a situation that they may not guarantee the compatibility, because they are still into experimental and alpha mode. So sometimes they might introduce breaking changes. You never know for the experimental part. So now let's see which component is in which stage. Okay, I have categorized them and broken down into these various topics. So let's say Kotlin slash JVM, we all know it's stable, right? And that's why we are using it. Kotlin is fully stable. There you don't have any surprises. Kotlin native or runtime. Um, so Kotlin runtime is okay, but Kotlin native runtime, it is still in beta. Some of the klib and these binaries are the binaries which I think trying to set the compatibility between your Kotlin code and iOS code. The expect and actual mechanism, the way you can differ or set up a contract between the shared module and the iOS and Android source set, it is in beta. Multi-platform Gradle plugin is in beta. Kotlin native interoperability with C and Objective-C in beta. That means they are still trying to optimize their Swift and iOS generated, Objective-C generated code. Cocoa Pods integration in beta, but much better than 2019, because at that time I remember I used to do everything manually. I run the Gradle task, I link them into the Xcode. It was very tedious process, believe me. But now everything is already there when you open Xcode project, which is great. Multi-platform ID support, they are getting there. It is in alpha, but much more towards the stabilization. The KMM plugin itself in an experimental stage. That means they might change something in Wizard. They might have some compatibility issue with maybe some of the Android Studio version, or maybe the Kotlin version itself. This could happen because it's in experimental state. Some of the references which I find very useful. So there is a official JetBrains tutorial. I think they explain the similar app, but there they are also explaining how the caching can be implemented using local database. So do take a look. It's a nice tutorial. I have set up a link to the companion app which I have created to explain all entire thing about KMM. So all the code, all the screenshot which you have seen in the presentation is part of that companion app. It is on the GitHub, open for public. Do check it out. Leave some feedback over there. There was a talk back in, I think, July or August, when the Kotlin 1.4 event happened, and the fantastic talk has been given by the JetBrains developer advocate itself. It's amazing. They are explaining some of the nuances there as well, which I'm not able to cover in my session. And then some of the FAQs, like how can I introduce KMM to my team, what things I need to take care before I start using the KMM, all those kind of a question. I think JetBrains is, as I said, they're collecting the feedback and they are well aware of what developers are facing. So they have nice draft in form of FAQ on this particular link. Do check it out. And that's me with KMM multi-platform. Feel free to ask me any questions. And thanks for your time. Thank you, Kotlin London, for the opportunity one more time.
Thank you. Can you see the questions?
Yes, let me open Slido.
Yeah,
Okay,
or can you?
yeah, so the first question is, how do you run your CI build in Kotlin multi-platform? That's a very interesting question. I think the way I would do is, so let's imagine you set up a KMM project. You set up your Jenkins pipeline and everything around that. What you need to do is, since you don't have Xcode or someone running your Xcode on when you set up a job on CI, if I go back, you might remember that there was a build phase which was using a Gradle task. We need to configure that Gradle task into your build pipeline steps. It's just like your any other Gradle task. So if you say Gradle W assemble so and so, you can say Gradle W shared pack for Xcode, and then this would take a while to build, but eventually set everything and creates a dot framework file for you. So it's possible to set up that steps on CI basically. Okay. Does KMM support Jetpack Compose? And if you use KMM plugin to create a new project, can you specify if you want to use Jetpack? Okay. So yeah, that was the question from Kobe, and I would say yes, that's possible, because on the view layer KMM has no effect. KMM is not trying to hijack your view part, and I think they are never going to do that. That's my assumption. And since KMM is not enforcing anything to do on UI side, you can use, of course, Jetpack Compose or the way you are doing nowadays, which is XML based. So yes, possible. I think there shouldn't be any surprises. I would suggest basically, yeah, go for it. Uh, Next question is also from Kobe. Can you not in HTTP client? Then I. So the question is that, well, I think this is about the problem where I was trying to explain why Espresso was not easy to set up. So yes, they support different engine. Like for iOS, there is iOS engine, Android, then there is a JS engine as well, because Ktor is also compatible with JavaScript. And that's where I was saying, when I got stuck into the problem, I tried doing the same. Where what I did is I tried to rely on the expect and actual mechanism, where let's say I define I want some HTTP client as an expect. Then in Android source set, I define using Android engine, and then on iOS source set, I define using iOS engine. But again, how do you use the same thing into testing? Because in testing, basically you don't get any instance to set your mock data on it, right? There should be some sort of if I relate with the HTTP, sorry, if I relate with the retrofit, there has to be something like interceptors, which maps to your dummy response. uh, they have put some blogs on their Ktor module, but it's very blurry. I think from a developer perspective, if you see, you would like to see everything together and not in bits and pieces. And nowadays it is in bits and pieces. So you would find how to configure your Android engine. You would find how to set up your shared module, but you would never find how you can do everything in the same module. Even on the test project which KMM has shared with us on their GitHub repository, it is missing all these bits. They haven't clearly highlighted how the unit test cases can be written. They haven't clearly highlighted how Espresso test cases are written, how iOS UI test cases are written. And I found that there are a lot of engineers who have already shared this feedback with them. Actually, some of the feedback were on the YouTube video itself on the JetBrains channel. So I think they have got this feedback, and hopefully they are working on it, and they might say us Happy New Year with that kind of a change. So give some time over there, I would suggest. All right, let's move to the next question, which is from Sherwin. How to write KMM library, not app? Is there any document or source for that? Hmm. I think you are trying to ask that you want to develop an independent module using KMM, and maybe mm, not use it in the way. directly like I showed you, right? So shared module was part of your overall Android project. It comes as in a same root level, and I think you want to extract it even from there, put it in a separate code base, and completely treat it as a separate code base. Um, so I think it should be possible. I haven't tried it, first of all, so I could be either like total wrong, but based on my exploration so far, I think you can do it. And the way you can do it is, and why I'm saying I can do it, because in the build.gradle file, if you check out my project, my GitHub project, which I would be sharing with the presentation, you can see that in the build or gradle file there is a source set, and the way source set are configured, and the way module is created, it is basically any other gradle project. And once it is a gradle project, once it supports a particular uh, directory structure using source set, I think it is easy to manage them on CI, easy to trigger a separate build, get the output from somewhere. So it goes same. You can say gradle build, it would start building, then create either a jar file, or basically the build folder. And if it is iOS related stuff, again you run the same task. You can say pack xcode, sorry, I think it was pack for xcode, yeah, something like that. So you run this task and it should generate you. But yeah, I'm not too confident. I would say I'm 70% confident that you can use it as a library, but rest 30% is bit gray area for me, to be honest. Okay. Any reason to, next question is, any reason to start the migration from bottom to top? Uh, yeah, because if you think, there is not really much to do on the UI side, right? So if you start from top to bottom, what you would do? There is nothing for you. So what you can do is, in parallel, you can have a shared module being developed. Maybe try using that shared API client with very, a tiny part of your app, which is not uh, carrying too much information or not having complex requirement. You can use it, to fetch maybe profile data, some of the contact details, really light requirement, see how it goes. Because your main application might be using other stuff like RX, or even Flow. Now you would try with Flow, since Roll explained it, right? So that's possible as well. You might be using Flow, you might be using some other kind of reactive programming, and there maybe situation would be a bit tricky. And that's why I explained in the slide that for existing project, it may not be that much straightforward. You may need to figure few things out, like from where to start. Start with the smallest module, of course, that would be the ideal. Start with maybe data classes. You can start putting your data classes into shared module. That would be a good start as well, and there is a no risk. So yeah, I would suggest you to start from the bottom layer only. Okay, having said that, I think there are no more questions, so I can hand it over to Enzo.
Yeah,
Thank you
thank you
once
very
again.
much. Thank you very much, Hardik. And if you like this talk, you can rewatch Hardik's talk back a few months ago. He was talking about flow, so it's very complementing with the talk we had with Raul. So thanks again, Hardik. Hope you can get you once again, like a back in the
Uh,
few months time, maybe.
yeah,
Get ready for
sure,
another talk. Thank you.
definitely.